Right, hello, welcome to another video, and it's been a little while since the last one, but I've been waiting for a little upgrade in hardware, which I now have. I've now got this beautiful tablet that I can use for writing. As you can, have I turned it on? It is now on, as you can see here. This makes writing a lot easier than before, where I was using my mouse. So as you can see, the difference is huge. I'm writing with the mouse now, and it doesn't even compare. I am still getting used to it a little, just making sure that I'm legible, but I'm not that I'm writing in straight lines. But I'm sure I'll get used to it over time. It's a great bit of kit, and I'm really happy with it so far. But yeah, anyway, let's get into this video. Along with this tablet, I also bought myself a book of maths problems. I believe this was problem number 3. No, it was problem number 6. It's problem number 6, and I thought it was quite fun. So I thought this would be a good problem to bless my new tablet with. So let's start. We have a quartic equation here: x to the 4 minus brackets 3m plus 2 x squared plus m squared equals 0. Then it says determine m so that the equation above has 4 real roots, all in an arithmetic progression. Now that's the real kicker, that's the real twist, the M. Night Shyamalan twist on this problem. Don't just determine 4 real roots, they have to be in an arithmetic progression. And what does an arithmetic progression mean? Well, it means that they are in the form of this, aren't they? They're in the form of, they increase by the same number between all the numbers in the sequence, have the same difference. So that's what we're looking for here. So say we had a root which was alpha, then it would have to be, I don't know, maybe 3 alpha, then 5 alpha, then 7 alpha. Or it would be alpha plus 2, alpha plus 4. In fact, that, I don't think that's strictly... Yeah, I think I would get away with that. Alpha plus 4, alpha plus 6, so on and so forth. The difference between each... the difference between each term would be the same. But if we actually look at our equation itself... it's a quartic, and not only is it a quartic, we only have the x4 to x to the 4, x to the 2, and then our constant, which means we can substitute. We could say let x squared equal y, and suddenly we have y squared minus 3m plus 2y plus m squared equals 0. And then we can find 2 solutions to that problem, and where each solution has to be then square rooted to become a positive or negative version of the square root. So then x would become a positive or negative square root of y, and we have those solutions. But going back to using alpha, if we were to say, now just say, since we're just using, these random variables, let square root of y equal alpha. So, x equals positive or negative alpha. We now have 2 of our 4 solutions, where one of them is alpha, one of them is negative alpha. Remembering that our 4 real roots have to be in an arithmetic progression, we now have 2 of our roots that are in an arithmetic progression. So if we imagine a number line where we have alpha here and we have negative alpha here, we can use this to find 2 more roots. Because we can work out the difference, we know they're in an arithmetic progression, therefore we can say, right, the difference between these 2 numbers is 2 alpha. So we can go up and say that another one of our roots could be 3 alpha. And we could say that, another one of our roots is 5 alpha. But, and you will see why I'm going to do this in a second, we're not going to go upwards, we're going to go backwards from negative alpha to get negative 3 alpha. And this turns out to be quite a fun little reason for doing this. In a second, we can use difference of 2 squares. So, we now have our 4 roots. We have negative 3 alpha, negative alpha, alpha, and 3 alpha. So, when we try and put these roots into our equation, so we substitute them into a bracket, x minus, and then our root, we get x plus 3 alpha, x plus alpha, x minus alpha, and then x minus 3 alpha. As you can see, we can difference of 2 squares them. So now we can have x squared minus 9 alpha squared. Make sure you don't forget to actually square your alphas, because it's tempting to just go, x squared minus 9 alpha. Nah, you've multiplied the 3 and 3's together. You've also got to multiply the 2 alphas together. And then x squared minus alpha squared. And when we expand this, we get x squared minus 10 alpha squared plus, I've given that wrong, that's a 4, x to the 4 minus 10 alpha squared x squared plus 9 alpha to the 4. And this equals our original equation, x to the 4 minus 3m plus 2 x squared plus m squared. So now we can just equate these things together. So our x to the power 4s don't really help us much, but the next 2 terms do. They're both negatives, so we can just ignore the negative and we can just say, 10 alpha squared, we're also going to ignore the x squareds, equal 3m plus 2. And then we're also going to say that 9 alpha 4 equals m squared. But we're not looking for the roots. The question doesn't want us to look for the roots. The question wants us to determine m. We can find the roots if we want to, but that's not what we're doing. We're looking for value or values of m. So we need to get rid of our alphas and only have terms of m remaining. The best way I found to do this was to take our equation 1 here, so we have equation 1 and equation 2, divide both sides of equation 1 by 10, so we're now left with alpha squared equals 1/10 of 3m plus 2, then square both sides, so we then have alpha to the 4 equals 1/100th of 3m plus 2 squared. Oh, that's new. Did not know I could do that with my little... don't tell me I've gotten rid of all my text. That's absolutely heartbreaking. And then if I press that button again... Oh, it's not doing it now. Okay. Well, that's annoying, but luckily this is a recorded video, so if there's anything you need, you can just go back and look at it yourself. We're going to go right to where we were, and where we were was, I believe, about to substitute in our manipulated equation 1, and I believe it looked like alpha to the 4 equals 100 lots of 3m plus 2 squared, which I'm just going to expand. So we have 9m squared plus 12m plus 4. So I'm trying to do this from memory. Our second equation had a 9 alpha 4, so we need to multiply this by 9. So we have a 9/100ths of 9m squared plus 12m plus 4 equals m squared. And now we just need to manipulate this into something where we have am squared plus bm plus c equals 0, and that's not too difficult. So we're going to multiply both sides by 100, and then this 9 we're going to bring into our bracket. So 9 times 9 is 81m squared. 9 times 12 is 108. 9 times 4 is 36. And if we times both sides by 100, we get this equaling to 100m squared. Now we bring everything over to one side. The 100 is bigger than the 81, so we're going to bring everything from the left-hand side over to the right-hand side so that our a in our am squared plus bm plus c is positive, which makes things a little bit easier. So our equation becomes 19m squared minus 108m minus 36 equals 0. Now we can't just factor this. I mean, I'm sure you could if you tried, but you'd be there for a while. We're just going to use the equation for x solving the quadratic equation. So we're going to minus b, so minus of minus 108 is positive 108, so we're going to say that m equals 108 plus or minus the square root of 108 squared. I'd write minus 108 squared, but it doesn't really make a difference. Minus 4 multiplied by 19 multiplied by minus 36 all over 2 lots of 19, which is 38. I'm going to save you a bit of time here. I've already done this. And conveniently, this big square root actually gives you a square number, which you can square root into a whole number. And that whole number is 120. So m equals 108 plus or minus all over 38. So when we find our two values of m, we have 228 over 38, or we have minus 12 over 38. Conveniently, this number here, this left-hand side value of m simplifies down to 6, and then this one on the left-hand side just becomes minus 6 over 19. And those are our two solutions. For m, determine m so that the equation above has 4 real roots in arithmetic progression. These are our two values. We have 6, and we have minus 6 over 19. I thought this was a really interesting video. Really interesting question, sorry. I mean, hopefully the video is interesting. Thank you for watching, and I'm sure I'll be up with another video soon, now that I have a much better setup. Thank you.